because that's one of the things I really care about, is doing stuff fast. You know, I hate waiting. I almost have ADHD, and so whenever something takes a long time, I kind of get really antsy and annoyed and bored and go and do something else. So one of the problems that we had at Yelp is that deploying our Puppet code, you know, you make a change in your Puppet code and you want to push that up to your master, and that was really, 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 really slow. I'm going to start this talk, I think, kind of at the end. So I'll tell you what the conclusions are, and then if you think it's boring, you know, you can go outside and have a cigarette, or you know, go and get some more lunch, do what you want. So yeah, here we go. So the speed of light is really slow, unfortunately. Certainly if you're like a worldwide organization, which we are, talking from the West Coast to Europe is slow. Talking from the East Coast to Asia is really slow. And that's a big thing, especially if you're doing multiple round trips. That's a really, really big thing. So I really like Git, and I'm afraid I'm going to disagree with the people from Twitter. I think that Git is pretty much the only way to go for your Puppet code. And the best thing about Git is that you can put your Git repository on your Puppet masters, and then doing a git fetch, it's only going to pull the changes. And that's going to be pretty fast. Or at least it's going to be damn faster than exporting Subversion. Damn faster. So what do I kind of really mean? I know, I'm getting ahead of myself. So eventually, as I was saying, we're a worldwide organization, and eventual consistency is the way you've got to go. We have a lot of Puppet masters and a lot of Puppet clients, and what we find is that, you know, at some decent proportion of the time, quite a few of these Puppet masters or Puppet clients can be down. So obviously with Puppet clients that's fine, because as soon as the machine comes back up, it'll run Puppet and it'll apply anything that's missed. But the same's true for Puppet masters. If all my Puppet masters have to be up for me to push code, well, that pretty much sucks. And yeah, so, no, centrally orchestrating global network is lol. It just doesn't work. When I say lol, I mean I cry. I cry when it doesn't work. Parts of the network will be down. We use a lot of in-house stuff and a lot of cloud stuff, and something's going to be down somewhere all the time. All the time, there's going to be something broken. So what I really need is eventual consistency. I need to know that my Puppet code is not just going to get from the masters out to all the clients eventually. I need to know that the code is going to get from my central Git repository up onto my Puppet masters eventually. Cool. So mcollective. I think mcollective is absolutely brilliant. It is a bit of a chainsaw. You know, you can quite easily take your knees off with it. But that's a good thing. And one of the kind of complaints that I've read most recently about mcollective is that, unlike an SSH loop or Fabric or something, you actually have this split between the agent, which is actually doing the work, and the application. And there's like DDL and an API between those. And that people have accused mcollective to say that this is not so cool for development, because you can't just change things and then it works. Again, it's pull rather than push. I think this is good because we have an engineering team of about 300 people, and so unless you put APIs in places, then people break things. So actually having mcollective services versioned is really awesome. Cool. So, okay, these are kind of key things I'm going to talk around a bit. But so what did we do? Where did we start? Where did we end up? How is that awesome? So what we did is a few months ago now, we replaced the way that we deploy Puppet code out to all of our Puppet masters. And we used to have our Puppet code in Subversion. It's now in Git, which is cool. We used to use an SSH for loop. We literally had a script that would SSH for loop around every one of our Puppet masters and push Subversion out to them. And we now do that in parallel with mcollective. And So all the users, that meant when we were pushing Puppet code out, every user who could push Puppet code had to be able to be root. And mcollective takes that away because it's got flexible policies. So you can say, you can push Puppet code to dev and you can push Puppet code to prod, and you don't have to do anything with pseudo rules. People who can push Puppet code do not have to be root. And that's pretty awesome because, again, we have an engineering team of 300 people, and 50% of that team is not operations. Therefore, the small operations team needs to support hundreds of engineers. So giving people the power to do their own changes, certainly in development environments, is a really important thing for us. And again, I'm going to say this at least a few more times. Pull systems are much better than push systems. They're much more resilient. They let you do eventual consistency. They're more tolerant to failure. Generally, if you can implement something as a push system or as a pull system, you need to have damn good reasons to implement it as a push system. Damn good reasons, because otherwise it'll bite you. Okay. I've said that I've done all these awesome things. How much did we actually win? How much did we win? Well, we had about a 4-minute deployment, 5 minutes on a bad day. So I make a change in Subversion, and I commit it, and I want to deploy it out to my Puppet masters. 5 minutes later, that's like, go and make coffee time between commits. That's not cool. That is so not cool. Because if I drink that much coffee in a day, I get even more excited than this, and nobody needs to see that. We now have a 4-second deployment. Just leave that there for a second. And we've got about 32 Puppet masters globally. That means that I push a Puppet change out to 32 different machines in about 4 seconds, which I think is pretty cool. Like 4 seconds is just long enough for me to go, oh, this is annoying, but that's fine. I only get mildly aggravated. As I said, I'm a pretty impatient guy. Well, if the last slide didn't convince you, well, I'm going to try to convince you some more now. So here we go again. Pull models, much better than push models. Eventual consistency. Again, if my Puppet masters are down, when they come back up, I want them to pull the latest code. In the same way that if a client's down for a while, when it comes back up, I want it to run the latest Puppet code and get the latest updates. And yeah, already said this, in a large network, you will have failure. 32 Puppet masters across the globe. What happens when the internet breaks in Australia? That happens. What happens when AWS, some of it breaks? We're in all the places in AWS, and so that means that some of AWS being broken is relatively common. And so actually what we can do is, because we've got a pull system, we can just make a cron job. And every hour, pull the Puppet code. Easy. On reboot, pull the Puppet code. Dead easy. And it means that for my deployment, when I want it to be fast, then I can actually use mcollective to make the Puppet code be pulled now, and that's cool, I get my 4 seconds. But it means that if systems are down, when they come back up, well, they can just use exactly the same system to pull the latest Puppet code, and they're immediately up to date. And so when I say the environments that you care about, this is definitely entirely environment-based, because one of the other properties that I want is fast iteration. And we want to not conflict with changes that other people are making. And so what we do is every Puppet change before it becomes live, that goes in a Git branch. And every Git branch becomes a Puppet environment. One-to-one correspondence. And that means that you can then go and run that environment on a specific node. You can say, run Tom's cool feature on this node, and if that one machine blows up, well, that sucks, but it's not as bad as I push this into production everywhere and it all blows up. And it gives you kind of less of a free-for-all than having 1 or 2 or 3 like dev staging tests. This is, again, where I disagree with Twitter. But that's fine. You can use my system to do a Twitter-like strategy too. It'll support any of these things. It doesn't care. Each Git branch is an environment, that's all. I'm just kind of saying how I use it. Cool. So yeah, environments, personal branches. So whenever I push a branch, or no, you can push a branch to one place just to save it, or you can push a branch to another place, and that gets deployed to every Puppet master. And then yeah, you just run Puppet manually or with mcollective in a specific environment, and you get the code from that specific environment. And it's a pretty nice way to develop things, because you can run things in no-op mode, or you can, what will this look like in the environment in Australia? Because I know there are some crazy things about the environment in Australia that are different from everywhere else. You can go run that, test one on the machines in Australia. Cool. And different teams can own different parts of the code, which is awesome. We have a really awesome search team at Yelp, and the operations team own the kind of boxes, but most of the infrastructure and search infrastructure they own. So it's really helped us delegate responsibility away from the operations team so that we don't have to make as many manual changes for people, which is cool. Right, and yeah, if you want to, this is the kind of strategy Twitter are using. You can do stage rollout by merging changes between branches. Any of these philosophies are, I may or may not agree with them, but they're all relatively valid, and they're all much, much, much better than having just the live code and testing by committing into production, or etc. Okay, so how the heck does this work? Who knows about environments in Puppet? Okay, few hands, few people lacking hands. So the only thing that you really need to do is you put a few extra things in your puppet.conf that you don't have at the moment. So for modules, you just put in your puppet.conf the module path is something like that, and that $environment gets filled in automatically. Every machine has a default environment called production. You can change this in puppet.conf if you want to, but it basically means you put your Puppet code in this one place, and everything will continue to work. But if you put another copy of your Puppet code next to it with a different name, and for me, that's just a Git branch, make another branch, push it up, then you can run Puppet, and you get a completely different set of modules. This works pretty much similarly for your site.pp. So you just put $environment in your puppet.conf again, just works. You can do this for hero data. This is a bit of a hack, I guess, but you tell hero that the data directory is like the root of your Puppet environments, and then you make your hero conf always include the environment like that, and so suddenly you've got your site.pp, all of your modules, all of your hero data, per environment. So you can make changes in a branch, test them independently for everything, and then deploy them with whatever strategy you want to do that with. The only thing this doesn't work for is manifests. Who has any code at all in manifests? Excellent. Excellent. We have hysterical raisins, and we're moving it out as fast as possible. In fact, one of the biggest, the speed at which people have been moving code out of our manifests into modules has gone up by about 100 times since we launched this system, because people are like, what, so I move this code from here to here and then suddenly I can test it? Oh, I see why you wanted me to do that now. It's just solved itself. So I'm going to go on a 2-minute Segue here just to be slightly angry. More than slightly angry. Refactor is a much abused word. It originally came from the kind of Java continuous testing, extreme programming type of background. And what it meant is changing the code in a way that doesn't affect what the code does using tests. Everybody, but everybody, mostly means refactor, just means change crap. So I'm giving up. The word refactor just means change crap. Sorry about that. Kind of like the word hacker cracker thing. You remember trying to take the word give up. Just give up. Just give up. Sorry. Okay. Sorry. That Segue end. Okay, so how does this work? I've told you about this beautiful 4-second deploy feature. What is actually needed to make this happen? So it's a custom M collective agent. And every Git branch is a Puppet environment. I've probably said that 9 times now. It's 200 lines of code. It's really not big. It's not complicated. I mean, actually, the tests are larger than the code itself. Dead simple little thing. And a cron job. And this cron job just runs the same code as the M collective agents once every, I can't remember, once every hour or something. And that gets me my eventual consistency for 1 line in cron, free, because I've used a pull model rather than a push model. Magic. If you design things right, then things become easy. Who'd have guessed? So yeah, the M collective agent also ships a CLI client with it. That CLI client is about 2 lines of code, maybe 3 lines of code. Tiny. Cron updates. Yeah, you can cron updates to just the branches you care about, like your production branch, or you can cron updates to all the branches. We actually stopped doing that because, well, I looked this morning and we have 317 branches in flight. And if you try updating 317 branches hourly, then your AWS Puppet masters that have no I/O are going to get quite unhappy. But that doesn't matter. If you're trying to test your code and the Puppet master you're trying to test on is down, well, you're not going to succeed in testing your code, right? So having to manually spend another 4 seconds re-pushing it when the thing comes back up is not a big deal. As long as everything that is a production branch that's being really, really used gets auto-updated, you're cool. Right, yeah, and that's the eventual consistency. So, detached work trees. Who's heard of this trick before? One guy. Congratulations, nobody's heard of this, which awesome. This is one of my favorite things about Git. So what we basically do is we check out the entire Git repository as a bare clone. So you say clone bare, you just get this pile of Git stuff. And we put that in /etc/puppet/puppet.git. And then with this kind of scary bottom line, you can just say Git, the Git repository is over here, but I want the checkout somewhere completely different, please. And that's awesome. Because it means that you only have to have 1 copy of a repository, even if you've got hundreds of checkouts, which saves you massive disk space. It's massively faster because you're only updating the checkout rather than the checkout and repository that you've got. And so we use this trick. And in fact, no matter how many branches you're changing or pushing or pulling, we do 1 update to grab them all, and then individual checkouts onto disk. This used to be, like the first version of this didn't bother with this trick, and it used to take 10 seconds to deploy, which was completely unacceptable. So I did this. Cool. So let's talk a little bit about some of the supporting technology. GitLite is basically, it's a Git server. It's just a bunch of scripts that sit around Git, but it gives you loads of awesome things. So you can just use Git like on your machine without GitHub, and that's fine. And in fact, you can just SSH into another machine and do a Git pull, and that's fine. If you have a login, you can use Git. You don't need GitHub or any server at all. Except for the fact that means that you have to have a shell account on every machine. That's not so awesome. So GitLite allows you to have role users. So I have a Puppet update user, and the only permission that user doesn't have a login. The only permission that user has is to pull the Puppet code. That's the only thing it can do. That's all it's allowed. And actually, GitLite has a load more facilities than this. You can get really crazy. You can have multiple Puppet update SSH keys, some of which are allowed to pull different branches. So this key is only allowed to pull dev branches. This key is only allowed to pull prod branches. We mostly don't use this sort of thing, except for we do payments. So we have a PCI payment environment, and so we start using this sort of functionality for this because we have a very restricted subset of people who can even log in to the payments environment. So this lets us split the permissions. It's really awesome. Okay, gotchas. So, this can't all be complete sweetness and light, right? Well, SSH by default ships with a concurrency limit of, I think, 10. So an SSH connection, you make the TCP connection, and then some things go down the TCP connection and back to authenticate. And SSH by default will only allow 10 connections that haven't authenticated yet. And this is normally not a problem. Even if you've got hundreds of users logged in, you normally don't have hundreds of users logging in all at exactly the same time, except I've got 30 puppet masters, all of which try and pull the code from Git at exactly the same time, within milliseconds of each other. So when I deployed this, I kind of found that a random selection of puppet masters would just fail egregiously every time, a completely different random selection every time. And I was very confused for 2 or 3 hours until I found this SSH feature. Okay, so what about if you have hundreds of puppet masters? Who here's got more than 30 puppet masters? Okay, only me. Fine, good. Right, we don't need to talk about this. And I'm going to kind of link to the code and stuff at the end, but I should fess up, there's some to-dos here. The documentation is mostly on SlideShare in about 10 minutes' time. Sorry about that. But like I said, it's only 250 lines of code. Even if you have to read 250 lines of code to work out what the hell it's doing, that's not going to take you all that long. And it's got tests, so it's cool. The M-collective part, there's an application part and an agent part, and the application part is really, really basic, and the output from it's really ugly, and it fills 2 screens with 32 puppet masters, and I'll fix that sometime. But it's not a big deal at all. And the kind of third disadvantage is that the M-collective packaging stuff supports agents and applications. It doesn't support my CLI script. So you basically need to take my CLI script that's 3 lines long, stuff that in your Puppet code, and deploy that yourself. Again, not a big deal, but kind of a to-do. It would be nice if the M-collective packager was able to package bin scripts that went with agents too. But the chance of me finding free time to work on the M-collective packager are relatively small for 3 lines of code. Okay, so I think that actually I'm running way ahead of time. At this point, it's links. So here's the code. Go find it on GitHub, all 200 lines of it. If you fancy 4-second deploys, if you fancy really rapid dev iterations, certainly if you're running Puppet Enterprise, you've already got M-collective for free. If you're not running Puppet Enterprise, I would recommend you get M-collective anyway, because it's awesome. Even if you don't want M-collective, you can still use this without necessarily having the M-collective parts, just by using the script that it ships with. Cool. So slides will be up shortly. You can tweet at me. And so I guess it's kind of almost questions time. But I'm going to ask you guys a question first. Can you guess what I'm about to say next? Go on. Oh, you have a question? No. You meant to tell me what I'm going to say next. Well, if nobody guessed, shame on you. Shame on you. Yelp's hiring. It's a superb place to work. We do cool stuff. We've got offices in Palo Alto and San Francisco. We've also got offices in these places, which you're probably less interested in. I work out of London, personally. You might be able to tell from the accent. It's a little giveaway. And yeah, that is it. And now actual real questions. Cool. Hey.
How do you deal with my question is, how do you deal with auto-scaling? And one step further, what kind of tool you are using to manage your cluster, for cluster management?
So the question was, how do we deal with auto-scaling? Do you mean auto-scaling Puppet masters?
Yeah. I mean, not necessarily. I mean, according to cloud usage pattern, sometimes you have, off season and high season, off season, off high season, as well as during the same business day, you have off peak time and non-off peak time. So, I mean, to reduce your cost, probably, most companies, they try to auto-scale the cluster.
So we're deploying a lot of our cloud-based SOA things using Netflix's Asgard. And there's something Handwave, I don't know, big data science, cleverer people than me, that produces what we're likely to need and then tweaks the ASGs for that. So we're doing some stuff that's really smart, and I know it's really smart, and I also don't know the details.
So that means, the size of your cluster and topology is fixed. Is that right?
So the size, the topology is fixed because we basically push stuff into almost every Amazon region and every AZ within that region. And one of the reasons we have so many Puppet Masters is that we deploy a Puppet Master to every AZ, which means that if US East 1 goes down, then that's fine. We lose those Puppet Masters, but no other environments can't have Puppets.
So most of your applications are typically non-real time is batch processing. I mean, is that right?
We've got we do a whole chunk of that, but we also have a lot of web stuff and a lot of web services stuff. That is all mostly scaled through Asgard and clever stuff that are just the ASGs that I don't know the details of. I'll come back to you next. Thanks. It's okay. Cool. Go for it.
Just a quick question. How would you explain in the simplest terms a use case from development code in the way Yelp has it set up currently, not with stage dev prod, but
what's the simplest case to explain that?
Like when you said, I'm sorry to interrupt, but like when you said you just kind of branch and you take the whole node branch and move it up one level.
So we also do code review, and we also use review board, but there's stuff in our dev code that never makes it into production. We explicitly don't have that problem because everything until it gets reviewed and shipped lives in its own branch, and that means that we can go and find 6-month-old branches that haven't been touched, that haven't got to ship it, and yell at people to either review it or go and auto-delete it or whatever. Which that stops a bunch of the problems that Twitter were talking about, and it basically means that we land things directly into production. If we have something that needs extensive testing, then what we'll do is we'll switch like an entire environment into a testing branch for a day to however long is necessary.
Thank you.
Does that answer the question? The gentleman over there?
A couple of clarification questions on your design. First of all, why do you have 32 Puppet Masters?
Because for every, well, we have a whole load of our own data centers that are the size that we need multiple Puppet Masters, and so that's, I don't know, probably 10 or 12. But we then, every single availability zone in Amazon, we make a VPC for that availability zone, and we deploy one Puppet Master into it, which means that every cloud region or every cloud availability zone is kind of self-contained, basically.
Okay. And then how do you do, so each region talks to its own local Puppet Master?
Yeah.
It never talks to the other Puppet Master?
Exactly, just so.
So you don't have a distributed certificate management problem?
We do not have distributed certificate management at all. And like Twitter, we're, for places where we've got more than one Puppet Master, which we do for the data centers that kind of we control, which tend to be larger, or at least they have less immutable machines and so run Puppet more, then we just do auto-signing. We are going to fix this probably in 2014, and I will probably be talking about how we fixed it in 2015. I know it's coming up, but at the moment we auto-sign.
And thanks for the Hira hack. I've been wondering about that.
Yeah, I mean, there's quite a lot of value to this, but I mean, I've actually been using this system for 2 companies long. If you look in the Git history, I originally wrote it at my last company and then stole it. I say stole it. We open sourced it at my last company. I then stole it and improved it for Yelp, which is significantly bigger. Isn't open source amazing? I've forgotten where I was going with that. Cool. Nobody on the left-hand side of the room's asked any questions. Just, hey.
So then are you sharing for your hybrid data since you haven't? Is it a clone setup? So all the ones in every availability zone must be exact same?
Yeah. So the question was, for our hire data, is it a clone setup? Does everything in every availability zone look exactly the same? And the answer is yes at the moment. We have been discussing, and we're probably going to do in the next 3 or 4 months, things such that we split out dev and prod and like the search infrastructure team that I was talking about earlier. We'll give them, like their test kit will be in its own environment. And so they will have a canonically correct, like their canonical search environment and search branch. And we'll do something such that we pull those changes back into our main production branch. One of the other nice things about Git is that if you merge, then you end up with if you merge both ways, you end up with exactly the same code. I know Subversion has got better at this, but it's still not the best in a lot of ways. So we are just doing one thing everywhere at the moment. This gives us the flexibility to do whatever else we want to do pretty easily.
You run into, I assume like for availability, some of your services also across regions.
Mm-hmm.
So you run into any interesting like coordination problems when you're trying to orchestrate like deployment or update?
So the question was, we're running cross-region services. Do we come across interesting problems trying to coordinate deployments that are rolling across regions? Yes. I'm not sure I've got a better answer than that at the moment. No, for the Puppet stuff, this is kind of simple enough that it's not a big deal. For our actual kind of main application, then the deployment system for that is significantly more than 250 lines of code and does have specific handling for that. I mean, we have things like we need to make sure that whenever we push a new version of a website, we need to make sure that we feed CDNs the latest version of all the images and stuff. So we actually kind of have specific handling in HA proxies for during deploys and all sorts of other fun stuff that should be the topic of another talk. So at the moment, the question was if we're doing a git pull from each VPC, where are we getting it from? And the answer is at the moment, everything, our kind of central Git server is one of the few things that is available from every environment, or at least our central Git server has an IP address that runs an SSHD that only runs Git, and that IP address is available from every environment. And we do a few tricks with local DNS, such that the actual IP address different environments see is different, but at the moment, 30 machines hitting one SSHD at once to pull Git, that's okay, that's fine, especially because all that stuff is going to be really hot in the file system cache. I just pushed it, milliseconds later, mcollective is making things pull it. It's still going to be in RAM. If we get to the point, I'm hoping we don't get to the point of having literally hundreds of Puppet masters. If we did, that would probably stop scaling. But at that point, I just need a second mcollective agent because the deployment becomes push, and then a Git hook pulls from the central Git server to subsequent Git servers, and then we did a Puppet update thing. Again, moving this system into something that will scale further, another order of magnitude of Puppet masters, will be real easy. It's one more mcollective agent that can do a Git pull. No big. At the back?
Can you give us a sense of your overall data center stack, what that looks like, and what your application framework looks like?
So the question was, can I give you an overall sense of what our data center stack looks like? I'm going to reply to that with another question. Do you want to know what our stack looks like now, or what the stack that we're working towards as fast as we can looks like?
A little bit of both.
A little bit of both. Okay, so we're a Python shop and MySQL largely, and traditionally we've got an application called Yelp main, which is really Yelp overweight or Yelp, oh God, I don't want to work on this. And that's kind of traditionally how things have been. We have started pulling lots and lots of things, and actually quite a lot of the functionality now in the website, like check-ins and badges and reviews is going fairly soon, but all of that is being pulled out into services that sit separate from Yelp main, because we can iterate and deploy on them much faster. And in about 6 months' time, those services will be in Docker containers. It is kind of where we're going. We use HA proxy for our load of balancing. We use S-tunnel, but we're moving to Nginx for SLM tunneling. What else is interesting? We're probably, or certainly looking really hard at the Airbnb Smart Stack stuff for service discovery. And search-wise, we do a lot of Elasticsearch and Zookeeper for coordination. So we're probably going to be moving towards Smart Stack, local HA proxies for service discovery, Zookeeper, etc. That's how it's going to be. What are we using for MySQL clustering? That's quite an interesting and good question. So we have basically a MySQL topology for replication, and we have a bunch of, that's a YAML file, and we have a bunch of tooling written around that. So obviously a master MySQL, and then we have what we call an intermediate master, which is we slave once from the master down to another machine. Everything else, or all the other data centers slave off the intermediate master, and then in each data center there's a master, and then things slave off there. The flippant answer to that question is Fusion.io. Because, well, no, we have kind of found that we have data centers or regions where we've got, I don't know, half a dozen, 8 MySQL servers. One Fusion.io card will do all the same work as them.
What were your pain points when you moved from SVN to Git and all your, like, how did the adaptability from the dev team, how did they adapt to your new process? So
I'm not sure if you've spoken to Mike, so I'm going to repeat the question. The question was, what were the pain points when we moved from SVN to Git? And I totally missed the second part.
The point I want to ask is, how did dev team react when operations team changed these things? And there are always people resistance to change because
I was continually hungover for about 2 weeks because people kept buying me drinks. Like our application main code is already in Git, and people were overjoyed, basically. I mean, no, that some of like our DBA team weren't that big a Git users, and so we had to spend a little bit of time with them, bringing them more up to speed. But generally, the reaction was, oh shit, 4 seconds to deploy, not 4 minutes. Well, crap. Oh, so I can develop this in a branch and test it in a branch without crapping on. Oh shit! Like overwhelmingly, other than teething trouble involving ActiveMQ and falling over, which caused some issues until we spent a bunch of time working on that. Getting a working global M collective, not 100% trivial, but other than that, people were completely overjoyed. It was the general reaction. At the back. So the question was, what's my...
Your take on virtualization. The reason I'm asking that is because classical virtualization typically is too heavy, And of course, they are lightweight and even inverse virtualization, you know.
Yeah, now that's a really good question. I mean, we're completely off topic, but that's fine. So what we do at the moment for services into Amazon is we have a Jenkins build that like takes a base AMI, runs Puppet on it, and we install the users and all the kind of base stuff. That then generates another AMI, and then every service, when we want to launch a new version of the service, we take our generic AMI, run some more Puppet code on it that's service specific, install the version of the service into it, bake a third AMI, and that AMI is what we then hand to, what's it called, the Netflix thing, Asgard. This is definitely kind of too heavyweight. I mean, the baking up one tray AMI thing is fine. The second level AMI, it means that like deploying a service into AWS takes at least 10, probably 15 minutes to bake a new AMI. The plan that we're probably going to go with, this isn't finalized, but the current thinking is that what we'll do is our base AMI will run Docker, and then we'll just inject exactly one container into each machine.
Cool, thank you.
Because that should be exactly the same and is nominally zero overhead and is certainly going to be much cheaper than baking a new AMI. The other nice thing about that is that it'll give us complete parity between services we're installing in our data centers and services that we're installing in AWS or third-party data centers. I think we've got time for one more question.
Yeah. Just a follow-up on your answer there. How do you manage all these AMI IDs and what's, do you have like you inject that into Hyra or?
Virtually none of that stuff actually is managed at the Puppet level. So as Jenkins builds that make these AMIs, and the kind of generated AMI ID becomes a Jenkins build artifact. And then when you want to change the version that's actually being run, there's another Jenkins build, and you can say, this service, take the latest successful build and that AMI ID, and inject it into Asgard, and then Asgard automatically deals with the pulling up new instances, tearing down the old instances, etc. So it's mostly a kind of Jenkins continuous integration build artifact workflow. Okay, I'm out of time now. So unless anyone's got a burning question, I think we're done. Cool. Thanks, everybody.